Alrighty, 12.4. We're going to talk about multiplying and dividing monomials, polynomials. This is Friday after sneak peek, so we are a little tired. We're going to sign a birthday card for Mrs. Thurber, so hopefully you said happy birthday to her today on Monday because it's her birthday. Okay, to multiply monomials, what we're going to do is we're going to multiply straight across and then we're going to reduce. So when we multiply, we can actually cross reduce first if we would like to. Let me take this. So on our numerator we have 7x squared yz. And on the denominator, we have 42x y to the fourth, z to the third. And so then what we go ahead and we're going to look at 7 over 42. We can reduce that to 1/6. X to the second over x. We'll use our exponent rules. We'll be just left with x to the first or x. Y over y to the fourth. Again, we'll use our exponent rules and we'll put y to the third in the bottom. Remember, our good way to remember this is we're always going to put the variable where the bigger exponent started, okay? And Miss Cash is showing you off to the side. Remember, if you do it the other way and you think of it as a negative exponent, we'll move it to make it a positive exponent. Okay, so then z over z to the third will be z to the second in the denominator. There's nothing else that we can reduce, so this is going to go ahead and be our answer. Of course, we can write it without the 1 in the numerator if we would like, but it's fine with it. Okay, let's go ahead and talk about a division problem. Remember, when we divide fractions, that's when we multiply by the reciprocal. So we're going to go ahead and we're going to rewrite this problem with 14z to the third, y to the third in the numerator, and 2zy squared in the denominator. Okay? So you can kind of cross off your second fraction there so it's not in your way. And then you can either first cross reduce or you can multiply straight across. So if we cross reduce the 14 and the 12, and again, if you do this cross reducing, it just makes your multiplication a little bit easier. Okay, so in our numerator, we're going to have 49 x squared y to the fourth, because remember we use our addition rule for exponent, and z to the third. And then in our denominator we have 6 times 2 will give us 12, z to the fourth, and y to the second. And now we're almost done. We need to make sure that we can't reduce our coefficients or reduce anything with our exponents. So we're going to go ahead and 49 over 12 is going to stay the way it is. We only have x's on the top, so we'll leave it as x squared. Y to the fourth over y to the second is going to be y squared. And then we'll just be left with z to the first in the numerator. And we have a special guest, Mr. Whale. Are you going to say hi and woo-woo? No? We're recording. Aren't you going to say hi?
I didn't understand that.
Yeah, woo-hoo! Hi, Mr. Whale.
Go Cash, go Novotny.
Okay, let's go.
Go Blackhawks.
Yeah, go Blackhawks is right. Let's go ahead and talk about multiplying polynomials. Okay, when we multiply polynomials, if you look at these first two problems, or the only two problems, if you want to foil and crazy foil straight across, you can, but you're nuts, because then you're going to have to factor that. So what we're going to first do is we're going to factor everything that we can from the two fractions. So when we have x squared minus 36, that's going to factor to, since we have a difference of perfect squares, that's going to factor to x plus 6 times x minus 6. We'll go to factor the denominator. That'll be x minus 6, x plus 1, times, we'll factor these other two polynomials, x plus 6 and x minus 1. And then our denominator will be x minus 6 times x plus 2. Now, since we're multiplying fractions, I kind of just take and make the whole top part a fraction and the whole bottom part the whole denominator. What we can do now is we can reduce and cross-reduce anything that's on the top that's also on the bottom. So that's everything on the top, and then we have everything on the bottom. So we're looking for things that we can cross out. So x minus 6 is on the top and the bottom, so we're going to reduce those out. Notice we have to leave the x minus 6 that still remains on the bottom, since now that we've crossed off the one on the top, there's not one remaining. There's nothing else that we can cross off, so our answer is going to be x plus 6. And you can either put squared or times x plus 6 again, and then x minus 1. And then our denominator will be x plus 1 times x minus 6 times x plus 2. If you would like to FOIL those or multiply them all back out, you go right ahead. We are definitely not going to make you do that this year. All right, let's look at one more example here. This one's a little bit different because when we look at the 3x minus 6, all we need to factor out is the GCF. So we factor out our 3, and then we're left with x minus 2. And then we factor the bottom, x minus 2, x plus 1, times. It might be helpful to put this over 1 so you can help visualize. And then this will factor to x plus 5 and x plus 1. Again, if you draw your big fraction line, that might help you to keep your work organized. And then anything that we can reduce out, we will. So x minus 2 and x plus 1 will also be eliminated. So all that we have left is 3 times x minus 5, or x plus 5, excuse me. You can write it over 1, or you can just leave it. And then for this one, you can either multiply it back out, or you can go ahead and multiply it to 3x plus 15. We do not care, or I don't care. Do you care? Yeah. Either way is fine, the 3 times x plus 5 or 3x plus 15. Either one of those will be good answers. All right, let's go ahead and talk real quick about division, and then we'll be done. Yay! Okay, remember divide polynomials? Typically when we do this, we're going to rewrite this as a factored problem. So we're going to have x plus 1 times x minus 1, because we're factoring x squared minus 1. Our denominator will factor to 2x plus 1 times x minus 1. You can do slide and divide for that. Remember, we talked about if a and c are both prime numbers, how sometimes it's easy to do trial and error in your head. Now this is where we have to be careful because we're switching to multiplication and we have to remember to flip our fraction. So now we're factoring 2x squared minus 3x minus 2, and that's in our numerator. So when we factor that, we're going to get we'll get 2x plus 1 and x minus 2. And then when we factor x squared minus 4, that'll be x plus 2, x minus 2. And now this is the same as how we did this before. Once we switch to a multiplication problem, this is the same as before. So we cross off our common factors. X minus 1 is out of there. Looks like 2x plus 1 is gone. And x minus 2. So do you see how we started with this massive problem and we're ending with this nice beautiful answer of x plus 1 over x plus 2? God, I love this chapter. Okay, let's go ahead and do number last real quick here. And we're going to go ahead and we're going to factor. Again, we're factoring 3x minus 6, so we'll factor out our GCF of 3. We'll factor our denominator to x plus 2 times x plus 3. Remember, we're writing a multiplication problem. Since we had no denominator, 1 will be our denominator, and then we can flip that. And then our numerator, or excuse me, our new denominator is x minus 2 times x plus 1. Cross off our common factors. divide them out. So we're reducing out x minus 2. We're left with 3 in our numerator. X plus 2 times x plus 3 times x plus 1. And there's our answer. Okay, make sure that you write down on the back of this sheet any questions that you have. Look at Miss Cash and her bubble work. And we will see you on Tuesday. And we have to go now because we just got invited to a very exclusive birthday party for Mrs. Thurber. So, later.